Done. Scrolling up, case 3 and 4. Total is 60 into 4, that is 240. Similar to this, I have also kept one or two problems that we will solve and we will start composition of two functions. So going to the next problem. In next problem, I think these are all the easy problems. You try at home, mark 59 and 60 as homework, give one try. These problems are again number of one function, or number of one function kind of thing, or number of onto. If onto you don't know about the partitions, you can use the formula thing. Partitions will be slightly trickier if you are not with us in permutation and combination. Now this is the next problem, problem number 66. In problem number 66, they have given the details. A is equals to ABC. B is equals to 1, 2, 3, 4. Then the number of elements in the set C. What is set C? Inside set C, we have functions defined from A to B. Under what things? Such that 2 belongs to f of A and f is many one, not one, it is many one. So here also we need to make sure in the range of function f of x there is an element 2, right? And we need to make sure the function f is a many one. So like I am taking this one or I am breaking this one in different cases. There will be a case when all three inputs are mapping to same output 2, right? So all three mapping to output 2. So like what is happening? A, B, C, everything is having same output, that is 2. What kind of function is this? This is clearly a many one. Clear? So how many functions we have like this? There is only one function like this. Am I clear in this? Now, next case. Once we have finished all three, we are decreasing. Any two is mapping to 2. Any two elements mapping to 2. So there are three different no A, B, C. For that, I should select any two, no? So 3C2. So we are selecting 3C2. Number of functions is equals. First, after selecting 3C2, what we did, we are mapping both of them to same output 2. This one we can do in one way. Now I'm not including the one there. Now the remaining is there, no? C. C has how many chances? C has 3 chances. Why 3? Because like we cannot include 2 again. All 3 mapping to 2 we already counted. Now we are saying like we are taking. C has 3 different chances. C can map to 1, C can map to 3 and C can map to 4. So this becomes 3 into 3, that is 9. Now I think this is last and final case. Case 3. In case 3, any one is mapping to 2. Any one element. This is little trickier. Mapping to 2. I need to make sure the function to be a many one function. So like let's say number of functions I'm writing here. out of 3, I'm selecting 1. The selected one we are mapping to 2. So like A, B, C. Let's say we are mapping A directly to 2. Now I have 1, 3 and 4. What I need to make sure the function should be B and C should map to same. So like now, how many possibilities are there for B and C? There are 3 possibilities. Select any one and then map them. So both B and C we are mapping to same output. So this is again 3 into 3 we have 9. Total functions like this is 19. Understood? Can copy this. What is happening? That side they are fixing something up. I'll drink some water. Yes, copy this. Done. Like this you can solve. I think this is last problem on this concept. Then I suggest this one also to do at home. 67. What we should do here, listen. F of 1 plus f of 2 plus f of 3 is equals to 3. So like consider the outputs and get f of 1, f of 2, f of 3 in such a way if I add I'm getting 3. Make sure I'm making like function is bijective, not breaking the definition. Clear? Try once. Next is composition of two functions. Like quickly I'll give you the definition and I'll directly go to the problems. So like composition of two functions is, in other words, connecting two functions. Any two functions we cannot connect, there is a restriction. Let's say function f is defined from a to b and function g is defined from b to c. Right? In that case, G composition F, G circle F is a function defined from A to C. What is G composition F? In G composition F, we have all such order pairs A comma B such that for all AB belongs to function F and BC belongs to function G, right? So like function F is giving the output B, this is F. Function G is giving the output C. Now the composition G circle F will work in this way. There is no intermediate in between, directly the final outcome you will see. That is G composition F. See, like in general, this is an important thing. G composition F is defined only if range of F is a subset, maybe equal also, or equal to domain of G. Range of F is a subset or equals to domain of G. In that case only G composition F is defined, right? See, like if we are writing for F composition G, in that case range of G should be equal or subset of domain of F. Clear? So I have given one thing, remaining you can write using this, right? This is an important property on composition. Let us take an example, right? In this example, what we do is like we are taking as two functions, right? Majority of problems composition defined only, but like in options, whenever they have mentioned does not exist, in that case, we need to be little careful, right? So now in this example, let us take function F and G, both are mapping from real to real. And then like f of x is equals to x square, g of x is equals to sin x. Now two things I'll find. First is G composition F. Second is F composition G. Here we'll understand the property. So like G of f of x will be equals to, like I can write the function f of x in this, right? So this becomes G of function f of x is x square. If G of x is sin x, G of x square is sin x square. Now the second thing, f of G of x, so this becomes f of sin x. F of sin x will be sin x whole square, that is sin square of x. I can clearly see that G composition F is not equals to F composition G. In general, composition is not commutative. Write this example. Maybe from here, anybody writing? Definition you are writing. Just some smallest one I have given. If you want, in our book, we have that proper definition. This condition is important. In general, I wrote, no, this is the important thing. They might ask a problem on this exception. They'll give a function f and they'll give a function g, and they'll make sure range of f is not a subset of domain of g. They'll ask the composition. In options, there will be an option satisfying the result, and there is another option does not exist. We need to be careful in that case. Done. One small example I have given. So now properties of composition we will see one by one. Before solving some problems, I'm changing maybe below I can write, I'll write here itself. In properties of composition, the property number one is in general composition is not commutative. In general, composition is not commutative. F composition G is not equals to G composition F. This is in general. Commutative property won't satisfy. In general, composition satisfy associative property. If we take three functions f, g, h, we can write associative property. I'm taking h circle, g circle, f. Maybe in this way we'll write h of g of h composition g composition f is equals to h composition g composition f. If I have three things composition, I can take first two and I do the composition, then the resultant again I'll do composition with the third one. This is associative property. You will see no in addition and multiplication. Your brother. After associative property, right, third one. Anything, let me see. No, that we will write one by one in detail. They have given the bisection only. Yeah, okay. Then we are going there. See, like not starting with bisection, we say composition of not only bisection, this is composition of 2, 1, 1 or onto or bijective functions are 1, 1 or onto or bijective. If f and g are 1, 1, then f composition g, if it defined, that is 1, 1. If f and g are onto, then f composition g, if it defined, it is onto. Same thing, if f and g are bijective, the composition is also bijective if it is defined. Now, is it necessary that if the composition, like listen carefully, if g composition f is 1, 1, then both may or may not be 1, 1. If one is 1, 1, that will do. Then f is necessarily 1, 1. G may or may not be 1, 1. I'll give you one example for this. Right? So like what I am taking, like I am taking one 1 function, one many one function. I will do the composition, I will get 1, 1. Right? So now this is a function f, and then function g also will define in such a way the composition what we get is 1, 1. So this is 1, 2, 3, and we have A, B, C, T. This side one more set we will define. P, Q, and R. This is G. Defined from A to B, defined from B to C. So randomly 1, 2, 3 mapped. Again 1, 2. So guys, if I see here, F is, what is F? 1, 1. Right? And what is G here? G is what? Many one. Then composition, what I am getting? G composition F. See, like G composition F, if you are not able to see there, you can draw here. This is A. This is C here. So 1, 2, and 3. So like 1 is mapping to A is taking that one to B. 2 is mapping to B is taking that one to Q. 3 is mapping to C is taking that one to R. So like this function over here is 1, 1, right? So like it is not necessary that when composition is 1, 1, both should be 1, 1, right? It is not necessary that both to be 1, 1, then only I'll get composition as 1, 1. Clear? Understood? This, huh? No, 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 no. Here F is 1, 1. F is 1, 1 only, no? Both are many one. In that case, like we cannot say anything. It may be 1, 1, it may not be 1, 1. Depends on the given thing. In general, I am speaking, if the composition is 1, 1, then F should be necessarily 1, 1. If I am taking something else, I won't get here. Clear? See here, G composition F is 1, 1. This is for 1, 1 thing. Next, the fifth property. In fifth property, you can take same example, right? If G composition F is onto, then G is necessarily onto. If I have composition as onto, for example, you take G composition of this one only, it is onto, and then you take here, same example I'm talking, G is onto. How onto? Every element from set C has at least one preimage. But if we consider F here, what is F? F is into, because there is an element D that don't have any preimage. But what we have in composition, G composition F is onto. Clear? Understood? This is fifth one. Now combining 4 and 5, I can write in sixth one, if G composition F is bijective function, then what we can say? Then we should say F is 1, 1 and G is onto. F is not necessary to be onto, G is not necessary to be 1, 1. If they are onto and 1, 1, there is no doubt it is definitely bisected. Not necessary, not required. Sufficient thing is 1 is 1, 1, another is onto. I have given for G composition F. You can do for F composition G if required. Right? So these are all the properties we need to learn in composition. So like next what we need to learn in composition is like how to find composition between two non-uniform functions. That is very important. Normal function if they have given, that we can do easily. Maybe one problem we will solve on this. Done? Copied everybody? You all have modules, no? These problems I didn't take screenshots. You can see the problem number 74 of page 40. Page 40, problem number 74. In this problem number 74, they have given that like for x belongs 0 to 3 by 2, right? Let f of x is given, function f of x is root x. And they have given g of x as well, g of x is tan x. H of x is also given, h of x is 1 minus x square by 1 plus x square. Now there is a function defined here, that is phi of x. Phi of x is equals to h composition f composition g of x. I can use the associative property to solve this. Now what they need, then pi of pi by 3 value, not difficult and all. If you know how to do the composition, you can find it. What we are doing, we know composition is associative, layer by layer we can do. This is h of f of g of x. So now substituting g of x, h of f of g of x is tan x. Now f of x is given. How much is f of tan x? F of tan x is root tan x. Now h of x is given. How much is this one? We get 1 minus tan x divided by 1 plus tan x. Even though I'm cancelling square and square root, I'm not writing modulus because x belongs to 0 to 3 by 2. 3 by 2 is 1.5. That is less than pi by 2 in quadrant 1. Clear. So now we need this we can write, no? This is tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. So how much is this? This is tan pi by 4 minus x. Now we need pi of pi by 3. Substituting in this, we get tan 45, that is pi by 4 minus 60. 45 minus 60 is minus 15. This is tan minus pi by 12. So tan minus pi by 12 will be equals to no option in this. So what we should write? This will be minus tan pi by 12. See, pi by 12 is 15 degree. It is negative value I got. If you check tan 5 pi by 12, it is 5 into 15, 75. That is positive quadrant 1. Tan pi by 12, 15 again positive. Tan 7 pi by 12, like it might be negative, but that is not equal. You consider tan 11 pi by 12. So this we can write as 11 pi by 12. I am talking about tan pi minus pi by pi by 12. So what is this? This is minus tan pi by 12. That is what we need. Option 3. This is the easy problem on composition. When they have given the functions are defined or like uniform functions. Uniform functions, I mean sin x, cos x, tan x, where function is not changing the definition. Non-uniform functions are like greatest integer of x, modulus of x, signum of x, fractional part of x. Function has different definitions in different intervals. For example, if we take mod x, that will be minus x when x is less than 0. That will be plus x when x is greater than or equal 0. That is non-uniform function. That kind of functions is what we are going to see now, how to find the composition. This is little trickier one. If you won't listen, you won't understand. Yes, please. Some doubt in
Can
this?
you explain how you convert minus 10 pi by 12 into 11 pi by 2?
Where? Here. See,
Yes,
this
sir.
one is equation number 1. I didn't change anything. I just wrote equation number 1. Now I am going for
Okay.
option verification. In option
Oh,
verification, this is tan 11 pi by 12. 11 pi by 12 I wrote as pi minus pi by 12. Using the
okay.
property tan 180 minus theta is minus tan theta I wrote here.
Okay, sir.
Right? Going to which one? 2. See, like first quadrant is 0 to pi by 2. Pi value is approximately 1.57. That's simple. See, like next we are seeing a problem. This is page number 41, problem number 79. Here in this problem, we need to find yes, F composition G we need to find in both they have mentioned F comma G are defined from set of reals to set of reals, right? And then like what is given? They have given that function f of x is equals to modulus of x minus 1. Like breaking the modulus should be your bread and butter. Like maybe the first one I am doing here. Always take the inside one and equate to 0. At that point I need to break. If I take the inside one and I equate to 0, I have only one root. That means only two cases. If I have two roots, I'll be having three cases. Clear? X is equals to 1 is the root. So taking case when x is less than 1 and when x is greater than or equals to 1. Take some random value less than 1, substitute in between x minus 1. Right? Keep the definition of modulus in mind. Modulus converts the negative things into positive by multiplying minus 1. If I take any value less than 1, let's say 0. If x is 0, then x minus 1 is minus 1, which is negative. If it is negative, what modulus does? It multiply with another minus 1. So the function when x is less than 1 is minus 1 into x minus 1. We will also write 1 minus x. Now you take any value greater than 1, for example 2. In this case, x minus 1 is 2 minus 1, that is 1 positive. If it is positive, modulus has no role to play. It just sends the same output. Clear? This is how I break the modulus function equating to 0. Only one root is there in that case, two cases. Two roots are there in that case, three cases, and so on. Clear? Now g of x also given. G of x is also a non-uniform function. What is g of x? G of x is equals to e to the power x when x is greater than or equals to 0. Next, x plus 1 when x is less than or equals to, you can remove equality from one case. It is not necessary to keep equality in both the cases. Even though you keep equality in both the cases, g of 0 value is 1 only. You can check that. In case 1, g of 0 na e power 0 1. In case 2, g of 0 is again 0 plus 1. Now, once I have the function, like what I need to find? I need to find f composition g here. Like there is no option saying that no such thing exists, no such function exists. So no need to worry here. This is f of g of x. Always find the range of the inside function g of x here. If it is g of f, you should find range of f. Find range or draw the graph of input function. Drawing the graph will be better in this case. Now drawing g of x. We can see that g of x is e power x when x is greater than or equals to 1. So like e power 0 is 1. Starting from this, it is an increasing function. It increases in this way and it reaches infinity. Clear? Now, when x is less than 0, g of x is a straight line. What kind of straight line? X plus 1. X plus 1 straight line, na slope is positive, y-intercept is positive, right? So it passes through this point 0, comma 1. X-intercept is negative. If you want, you can check. This is minus 1, comma 0. This is 0, comma 1. It is y is equals to e power x. It is y is equals to x plus 1. Once you have drawn the graph, keep this graph aside. Now we are finding, listen carefully, f of g of x. Go to the definition of f of x, replace x with g of x. What I should write? I should write 1 minus g of x when g of x is less than 1. Wherever there is x, there I wrote g of x. Now, g of x minus 1 when g of x is greater than or equals to 1. Now, this function depends on this inequality or depends on this one. When is g of x is less than 1? When is g of x is greater than 1? G of x means like this is your g of x, right? Now, this is y is equals to 0 line. Now, y is equals to 1 line I am drawing. This is y is equals to 1 line I have drawn. Now, g of x is less than 1 implies the graph of g of x lies below the y is equals to 1 line, right? So, in this case, I can write that implies that. Now, you see below the graph is this portion what I am highlighting, right? So, now this portion is there in between what? It is there in between minus infinity to 0. You can include or you can exclude. There is no problem in that. Clear? Understood? Right now, when is g of x is greater than or equals to 1? Right? So g of x is greater than or equals to 1. In that case, like you should identify the portion which is lying above the line y is equals to 1. Now, this is the portion which lies above the y is equals to 1 line, right? Now, this portion, if you have like now after identifying, it lies right side of the axis. Right side of the axis na greater than 0. This implies I should write 0 to infinity open bracket. Clear? Understood this one? Any doubt in this? Right? So solving this inequality is the important step. Now you go back g of x definition. G of x definition you can substitute in this. If we are substituting g of x definition here, what we get? We get 1 minus. What is the definition of g of x? When x is less than 0. When x is less than 0, g of x is x plus 1, writing x plus 1. 1 minus x plus 1 and writing the interval x is less than 0. X, this is x greater than or equals to 0. In that case, the definition is e power x. We are writing e power x minus 1. This is when x is greater than or equals to 0. Simplifying more, we have minus x. When x is less than 0, we have e power x minus 1 when x is greater than or equals to 0. Now the options are asking about 1, 1 and onto nature of this function. So I am using graphical method to check the 1, 1 and onto nature. This is x is equals to 0. E power x minus 1. It is a graph of e power x, but we are shifting 1 unit downwards. So if I am shifting 1 unit downwards, it starts from origin. When x is 0, e power x minus 1 is 0. Now from here, it is some increasing function like this. It will go. Now you take minus x. Y is equals to minus x means it is a straight line in second quadrant. Clear? So now the given function I can clearly see it is not 1, 1 function. Why? How I am telling? Using the horizontal line test. There are 1, 2. This says if it is y is equals to k, for same output there exist two inputs. So this is x1 and x2. Given function is not 1, 1. For onto thing, I can see the range of this one is starting from 0 till maybe going till infinity. Range is not equals to codomain. So therefore the function is neither 1, 1 nor 1, 2. Again, please listen. They have given two functions f and g, both are non-uniform functions, right? So like what I have identified, I have seen the input function. I have drawn the graph of input function. Now going to the f of x, replacing x with g of x, I have something like this. Next step is solving for this inequality g of x is less than 1 and solving for this inequality g of x is greater than or equals to 1. Clear? So how I solved? Using the graph. Equals to 1, I have drawn a line. Above the line and below the line, I have identified. Using that identification, I got x values, x interval. G of x interval is there. We converted that into x interval. That is important and difficult thing. After doing that, we have got the function, substituting it, and this is the function. Please express if you have any doubts. Ask. We will do one more problem like this.
How it is not on to
Range I can see no in the graph. Every graph, like every portion, what I have is like maybe you take in onto for every real number, there should be a pre-image, right? Now I am taking this as y is equals to -1. The line y is equals to -1 is not intersecting the graph, implies that y is equals to -1 has no pre-images. If it does not have no pre-image, it cannot be onto. Clear? Some doubts? Somebody said something.
Sir,
Yes, please.
sir, explain the graph once again, sir.
Like how I have drawn the graph, huh?
Yes, sir.
See, like if you are there in 11th grade with Akash, you will be knowing the graph of e power x. This is like normally e power x graph looks like this. They just need the portion when x is greater than 0, so I removed this part. Now, when x is less than 0, we have y is equals to x plus 1. Y is equals to x plus 1 is a straight line. Slope of this straight line is equals to 1. Y-intercept is also 1. X-intercept, if we are calculating, we will get x-intercept -1. Using slope, x-intercept and y-intercept, I have drawn the straight line in this way. This is the straight line. Am I clear?
Yes, sir.
Thank you. Maybe they are writing more. Is this okay? Next, a similar kind of problem. 65 we will do. Same page 60, before page 60.
ఎవరు అనుకుంటాయి కదా 3 పేర్లు జాతి సౌండ్ Maybe they will
See, similar kind of problem is 65. That again I'll teach. Finding composition between two non-uniform functions is not easy. It's a very difficult one. Might take some time. Please listen carefully. You guys copied this, right? So now in 65, see the problem. Two are functions f and g again, defined from real to real. There is no point like then no option is asking about the existing and does not existing of the composition. Right, I think this is page number 40, problem number 65. F comma g defined from set of reals to set of reals. Right, now functions is f of x is equals to, what is this function here? Log x base e, that we can write as ln of x. Ln of x is natural logarithm with base e. X is greater than 0. And then next is e power minus x when x is less than or equals to 0. Function g of x is given. What is g of x? G of x is x when x is greater than or equals to 0. E power x when x is less than 0. Now we need to find G composition f. G composition f is also from real to real. Now to find this, I need to draw the graph of f of x, or I need to know the range of f of x, right? So we are drawing the graph of f of x. First we are drawing log x, graph of log x. It is again increasing. It starts very near to 0 and it goes till infinity. This is the point of 1 comma 0, the x-intercept. E power minus x, right? E power minus x is given only when x is less than or equals to 0. E power minus x is a decreasing function. It decreases from positive infinity and it reaches when x is 0, e power minus x will be 1. So this is y is equals to log x. This is y is equals to e power minus x. This is y is equals to 0 line. Right? So now what we are doing? We are going g of x and we are replacing x with function f of x. Everywhere, wherever you see x in g of x, write f of x. So g of x is x. So it becomes f of x. When it will be x? Whenever x is greater than 0, this implies whenever x is greater than or equals to 0. Right? So next, e power x is given. This becomes e power f of x whenever x is less than 0. Oh, sorry, not x. This should be f of x is less than 0. Now, important and difficult step is here. We should solve for the interval of x here, solve for the interval of x here. F of x is greater than or equals to 0 means I need to draw y is equals to 0 line, right? Greater than or equals to 0 means above the line. Less than or equals to 0 means below the line, right? Now, in the first case, greater than or equals to 0, we have these all things with us. Am I clear? It is lying above, no? Or it can be this one as well. Am I clear? Right? So now once I identified, one moment, please. Once I identified here, next what I need to do? After this, I need to write x belongs, right? So this is x is equals to 1 starting from 1. I am asking equality is there, equality is there. Equals to 0 is there, no, I can include, right? So one thing is x greater than or equals to 1. There is no doubt in that. Clear? Any doubt in this? Now next, this part is there, no? This part entirely is like, we can say R. This is when x is greater than or equals to 0. Like equality 0 depends here. If you want, you can keep, or if you want, you can remove. Clear? Understood? Any doubt in this? Anybody? Right now, second thing, f of
Sir,
x less
less
s,
than
please.
equal to 0 only, no, sir.
Sorry.
Less than or equal to 0 only, no, sir.
Yes. Less than or equals, I should write, not greater than. Thank you for correcting me. It should be less than or equals to 0. Like this side, no? This is x is equals to 0 line. This side, I have negative value of x only there, no? If I observe like this entire graph, it is starting from minus infinity x value and it is reaching 0. Clear? That's only less than or equals to 0. If I observe this entire graph is starting from x is equals to 1 and it is reaching x till infinity. It is there, no? Towards it. That's why greater than or equals to 1. Clear? Now, f of x is less than 0. F of x is less than 0 means this part. F of x is less than 0. When it is less than? It is less than in this boundary. This is x is equals to 1 line. This is x is equals to 0 line. Neither 1 nor 0 is included in this. Understood? Understood how I wrote this intervals? Like first there is a, I am explaining again, please listen. Like they have given f of x is greater than or equals to 0. I have seen the graph of f of x. I have identified the portions which lies above the x-axis. There are two different portions. This is portion 1 or first part. This is portion 2 or second part, right? If I talk about second part can be like the x value we can take anything greater than less than 0. In this direction if I go, the second part only I have, there is no doubt in that. Clear? Now the first part if I want, like now the first part is starting at x is equals to 1. If I start at this, if I go in this direction, whatever value of x I have taken, the graph is lying the above only, no? So I can take. That's what I wrote, x greater than or equals to 1 or x less than or equals to 0. Now, in the last case, when f of x is less than 0, I have identified the portion which lies below the graph. Below the graph portion is like x is starting from 0, not included. The moment I reach 1, f of x is 0. That means I should not include 1 as well. All real numbers in between 0 and 1, excluding 0 and 1. Clear? Understood? Now, once I finish this, right, what I need to go, like you go back to the definition, like maybe you write in one step, this is function f of x when x is less than or equals to 0. This is e power f of x when 0 less than x less than 1, right? F of x when x greater than or equals to 1. So I wrote in ascending order, right? Minus infinity to 0, 0 to 1, 1 to infinity. Now when x is less than 0, go to the definition of f of x. When x is less than 0, what is this? It is e power x. Write e power x in that. Yes, please. It's raining outside. Okay. This is when x is less than 0, we have e power minus x, e power minus x I wrote. So like listen carefully, when x is there in between 0 and 1, this portion, it is log x. So I should write e power log x when 0 less than x less than 1. Now when x is again same, this portion again same definition. Here I am writing log x when x is greater than or equals to 1. Right? Now we need to identify this function whether it is 1, 1, on 2 or not. Again, the identification can be done using the graph. So how to draw the graph? You should know e power x graph. E power log x is x. Clear? So this is e power minus x graph. And then like next, it is directly x. 0 not included, 1 also not included. Y is equals to x line. After this, it is log x. Log x is starting from 1 going till infinity. Something like this. Now this function I can claim is not 1, 1, horizontal line test failing. Again, not on to horizontal line test only failing. Neither 1, 1 nor on 2. Anybody, any doubt in this? That heavily it is raining, ah? In rain and all you came, ah? E power log x graph I didn't draw. It is like, listen, e power log x is equals to x. E power and then log got cancelled. Just x graph. It is y is equals to x line in the interval 0 to 1. Thank you. Some other doubts? Copied, ah? Right. Now, in composition, I want to teach one problem, that is a problem on exception. Page 51, problem number 6. What's your good name?
Visagan, sir.
Visagan. Books are wet, ah?
Yes, sir.
What was? Scrolling down. What, he cannot draw that, huh? Graph you are not able to draw.
He is copying from my note. I
Right.
only drew.
If you cannot draw these graphs, I can tell you one thing, in engineering there is something called engineering graphics. I have studied. I'm not sure for you it is compulsory or not. If it is compulsory, you are going to suffer in that. Like in my life, I came to know there are types of pencils as well. 1B, 2B, HB, 1H are some random names I didn't remember exactly. In movies and all, you will see, the blue color bag, one right 90-degree thing. That is known as drafter. With that, they'll play with your life. Conclusion, it is neither 1, 1 nor on 2. I don't think in
Sir.
some call. Yes, please.
Sir, why we draw the graph line in below, sir, when you moving on to
When we are proving onto, we are drawing below because let's say this is y is equals to one line. I am assuming like for g of f of x is equals to -1 has no pre-image. If it is not intersecting na, no pre-image only no.
Yes, sir.
No pre-image na, not onto no.
Okay, okay, sir.
Understood? See, like page number 51, problem number 6, that will be the last problem on composition, what I am teaching. So you would have seen that problem. What is the given function? Given function f of x is tan x. The given interval x belongs to -pi/2 to +pi/2. Next, g of x is equals to root of 1 minus x square, right? So again, if you want x belongs to closed bracket -1 to +1, domain I have found by taking the inequality 1 minus x square greater than or equals to 0, x square minus 1 less than or equals to 0 from there. Now they are asking us to calculate g of f of x, like without checking anything. If I'm going directly, I should write this one as g of f of x is tan x. Now this becomes a root 1 minus tan square x. So maybe I should convert this sine and cos. It will be 1 minus sine square x by cos square x. The numerator we will get is root cos square x minus sine square x divided by cos square x. I can write this one as maybe a root cos 2x by denominator is what? Just cos x, because like cos x is positive in the interval. Like what is my claim over here? This is not correct. One option is there, no? Option 1. What is my claim? This is not correct. Why this is not correct? Like if I see here a range of the function f of x, what is range in this? It is -infinity to +infinity, right? So now what is the, we can say a range, sorry, not range, domain of the function g of x. Domain of g of x is -infinity to -1 to +1. So range of f is neither subset nor equal set to domain of G. This implies G composition f is not defined. I can clearly prove this like another way of doing this. You take x is equals to pi/3. What is G of f of pi/3? We get root cos 2pi/3, correct? Divided by denominator cos pi/3. Cos 2pi/3 is what? Negative only, no? Root of -1 is imaginary, not defined. Understood? So
Yes,
this
sir.
is about composition. Tomorrow I won't be available, so no doubt class tomorrow. Monday again, 4 to 5:20 we'll schedule. In during Monday's class, I'll try to finish inverse. Once I finish inverse Monday, Tuesday this periodic and even odd function. If one more class on Thursday, that will be on how to find domain and range of a function. That is the last. Clear? If you have any doubts, you can attend. Next, I think you have a class. I'm packing this. No doubts means. Online students, any doubts in this? Anything you want to add? Everybody copied
sir.
this? So I just want to talk with online students. Yesterday, one student messaged me. Kirti Sri is there online.
Yes, sir.
Today we are conducting one doubt session. Again, that doubt session is for inverse trigonometry. Maybe in that one inverse trigonometry equation I will solve. You can see in that. After that, you can try solving more problems.
Okay, sir. Thank you, sir.
I have mentioned now like Monday, Tuesday and Thursday, 3 classes I am spending on functions. Right? Again, please don't come and ask me to repeat some concept. Monday, inverse of a function and problems on inverse. If time allows, periodic or even odd, we will see that day itself. Then some other day, whatever remaining. If we have more time, one day we will do problems of functions. Clear? Right? Is that okay, guys? Anybody has problem attending 4 o'clock session?
No, sir.
The best I can make is 4:30. More I cannot delay. 4 to 5:20 or 4:30 to 5:30. Another thing is not there. I am not giving any doubt sessions or something for inverse trigonometry. In general, if you want, you can approach me in offline. Clear? So anything else? You can give any suggestions. I am new to this place. I don't know how previous teacher used to do and what they used to do. So you can suggest anything. I want your suggestions on teaching pace. I want your suggestions on problems. Like, am I teaching too slow for you guys? You want me to increase the speed? You can say I don't have any problem. Okay, what the speed? Can I increase little speed? No. We'll try, maybe. What I am doing now is like my normal thing. What few students told me is like I'm little slow, they are telling. Maybe I'll work on that. Give me a week or 1 month time. Later we'll do. Then about problems. Is that okay? The problems what I am doing, like you want more problems. Inverse trigonometry you would have attended, no? In inverse trigonometry, I am teaching all models, not majority of problems. Clear? So this is what I used to do. If you want, maybe I will try to include more problems. Okay. So like if you have any problem in this understanding the advanced PYQs or you want more, you can talk to me. I will add or I'll do according to that. Right? If you have problem in understanding advanced PYQ, what I suggest is like, don't listen to this solution. What you do is like, you pick the module and then you solve some step 2 problem in that. If you already solved that problem, right? Again, in the same way, what I will do, what I will suggest you is like, you keep the module with you, maybe carry one rough note, start solving some other problems. Clear? Understood? Right? I don't have any problem unless until you are doing maths inside classroom. I'll be having problem if you play game in class, if you text with your friends in class, if you watch IPL match, if you do some other subject. Clear? So then if everything is okay, online students, any suggestions? No suggestion means you can leave. Please join us in doubt session of inverse trigonometry. Shivkumar suggesting something? Thank you.